Hey everyone, welcome back to another video of LeetCode Daily Challenge Streak series, and in today's video we have a new question that says least number of unique integers after k removals. Given an integer of ARR and an integer k, find the least number of unique integers after exactly removing k elements. So you'll be given an ARR like 5, 5 and 4, and you'll be given an element k. Now you're supposed to return the least number of unique elements such that you can only remove one element. Okay, you can one as in k elements. So here k is equals to 1. So you're supposed to return the number of unique elements in an array after removing k elements. Now what can we do to return the least number of unique integers? If a number is unique, okay, the first point here is that if a number is unique, it means that it occurs only once. Okay, it occurs only once. So the frequency of this thing is only 1. But the question says you're supposed to return the least number of unique occurrences. Okay, the least number of unique integers. Okay, for you to have least unique elements, what is the opposite that you should have? What is the one thing that you should have if you shouldn't have least unique element? If you want least number of unique integers, what should you have? You should have more number of frequent elements, correct? If you have least unique elements, if you want least unique elements, then you'll need more frequent elements. Now let us first write down the frequency of these elements. Now you can see that 5 here occurs 2 times and 4 here occurs 1 time. Now when k is 1, okay, when k is 1, it means that you can remove any one element. Now let us assume that I remove 2 elements of 5. Okay, I will remove one element from the 2 elements of 5. So I'll be left with 5 comma 4. Okay, I'll be left with 5 comma 4. Now what is another way that I can think of? Now what I can do is I can remove one occurrence of this 4 and I'll be left with 5 comma 5. Now I have 5 comma 4 and I have 5 comma 5. But what does the question say? It says that we should have the least number of unique occurrences. Do we have the least? So here we have 2 unique elements. Okay, in this we have 2 unique elements and in this we have only 1 unique element. So which one will you return as answer? You will return this one as answer because this one has least number of occurrences. So if you carefully observe what we've done here, we have eliminated the elements. Okay, we have eliminated the elements that have less frequency. Okay, the elements with lesser frequency, if we eliminate them, then we'll have the elements with more frequency in turn giving us more frequent elements. Okay, if we want more frequent elements, we should remove the less frequent elements. Okay, less frequent as in unique or less frequent elements. Now what I will do, now let me take a different example. 4 3 1 1 3 3 2 and k is equal to 3. Okay, now what I'll do, I will just again note down the frequency of all these elements. So 4 here occurs 1 time. Okay, now 3 here occurs 3 times. Okay, 1 occurs 2 times and 2 occurs 1 time. Now if you can see here carefully, now k is equal to 3. It means that I can remove any 3 elements. Now what is my one of the options where I can remove 3 elements? Now here 3 occurs 3 times. So I can directly remove 3 here. Now what elements I'll be left with? I'll be left with 4, 1 and 2. But how many unique elements I have here? I have 3 unique elements. Okay, now what I'll do? Now instead of removing this 3 here, what I will do? I will remove this one occurrence of 4, this one occurrence of 2 and one occurrence of this 1. So what will I be left with? I'm removing 4, I'm removing 1, and since I have 1 comma 1 here, since 1 occurs 2 times here, I will remove 1 occurrence here. So I will be left with 1 comma 3. Okay, I'll be left with 1 occurrence of 1 and 3 occurrence of these, which would be 1 3 3 and 3. Now how many unique elements do I have here? I have 2 unique elements, correct? I have 2 unique elements. So my answer for this one would be 2. Now, how can you put this into the form of a logic? It's very simple. You first take the frequencies of every element like this and you sort them in ascending order. Okay, you sort them in ascending order. So what will this thing look like? It will look like 2 occurs 1 time, 4 occurs 1 time, 1 occurs 2 times and 3 occurs 3 times. Now, if you start from the beginning, initially your k is equal to 3 as per the question. You are supposed to remove 3 elements and initially you have not removed any elements yet. Okay. Now, what you will do is that after sorting this, you will traverse through this particular hash map or frequency array and you will check for the frequency of this particular element. Okay, you will be checking for the frequency of these elements and you will check for the number of elements remaining to be deleted. Okay, first I will come here. Now 2 occurs one time. Now if 2 occurs one time, what I did here, I eliminated it. Correct, I eliminated it. So what I will do, I will decrement the frequency of this existing elements with respect to k. First I will check if the number of elements to be deleted are greater than or equal to the frequency here. Okay, meaning if for example I have 2 occurs for example 4 times and I'm only supposed to delete 3 elements. If I'm only supposed to delete 3 elements and I have 4 occurrences here, what I can do, I can remove 3 occurrences of this 2 and I will be left with 1. Correct, I will be left with 1. So what I will do now, instead, for example, I have 3 occurrences of 2. Okay, if 2 occurs 3 times, what I can do, I can directly remove all the 3 occurrences of this. How will I do it? I will simply decrement the occurrences with the number of elements that are present here. So what happens now? My count of 2, okay, my count of element 2 is equal to 0. Okay, now 2 has 0 elements. Now next, what I will do, now what is the value? Now when you came here, initially k was 3. Now I traversed through 2, element number 2, which had 1 occurrence. So since it had 1 occurrence, I removed it. Now what is my frequency? Here it only occurred once. So frequency is equal to 3 minus 1. So my currently k is equal to 2. K is equal to 2. Next I will move to the next element. Do we still have elements to deduct? Yes, we still have elements to deduct. So are the number of elements for 4 occurring for the occurrences of 4, is it less than 2 here? Is it less than 2 here? Yes, because we still have elements to decrement and we also have elements that occur less than this particular number. So what we'll do, I will eliminate 4 again. So k is equal to 2 minus 1. It means I eliminated one more element and now k is equal to 1. It means that I am supposed to eliminate one more element. Okay, I am supposed to eliminate one more element. Now when I eliminated this element here, what happens when I eliminate the frequency of this particular thing here? When I am doing k minus equal to frequency, it means that the frequency of this particular element will be 0. Now 4's frequency is also 0. Correct? Now next, what? K is equals to 1. When k is equals to 1, I will go here again. Okay, when I will go here again, what is happening? If k is equal to 1 here, what is happening? Am I able to delete any more elements here that are unique? No, I am unable to delete any more elements here. Why? Because I am supposed to delete how many elements? I am supposed to delete 1 element here, but the occurrence here is 2. It means that even if I delete 1 element, this element will still be there. Correct? So how many elements will I have? I will have 1 element. This element will already be there. For example, my k is equals to 1. Now k is equal to 1 and this 1 here occurs 2 times. So even if I remove this, okay, even if I eliminate one value, I will still be left with 1 element and k will be 0. So no matter how many times 1 occurs, I'll still have this 1 element as my unique element in this particular array. Correct? Now if k were 3 and 1 occurs 2 times, then I would have directly deducted the number of occurrences. Then 1 would become 0 and k would become 1 because I eliminated 2 elements. But here if my 1 occurs 3 times and if I can only remove 1 element, my 1 would still occur 2 times. If my 1 would still occur 2 times, it means that it will be present in the remaining elements array. So it will also count as one unique integer. Correct? It will also count as one unique integer. Now, this is where you're supposed to break the loop. This is where you exit. You keep deducting all the frequencies of these elements, okay, these elements until k is less than the frequency. The minute k is less than frequency, you will exit. Okay, only if k is greater than or equal to frequency, as in if k is equal to 4 and my frequency of 1 here is 4 or 2 here is 3, if it is greater than or equal, that is when you can eliminate and k becomes 0. Okay, the minute k becomes less than frequency, you will exit the loop. Now what are you going to do next? You saw that while I was eliminating the elements, I was also making sure to update their count to 0. So here 2 became 0, 4 became 0, 1 occurrence was 1 and 3 occurrence was 3. Correct? Now what I will do, I will iterate through this hash map again and check for the frequencies that are not 0, because I want the count of unique integers. I don't want to see how many times they are repeating. I just want to see how many elements are occurring in the end after elimination. So after elimination, whatever frequencies are greater than 0, you will just count those and return those. So here 2, 4 are eliminated, so their count is 0, I won't count. Here for the count of 1, frequency is 1, so I got my 1 element. Next, for 3, the frequency is greater than 0. Yes, I got another element. So totally how many elements? 2 elements. So I have 2 unique integers, okay, 2 unique integers after eliminating k elements, okay, after eliminating k elements. Now what is the time complexity of this thing? The time complexity of this thing would be O of n log n, since I am sorting the elements here, okay, since I am sorting the elements here to get their frequencies in order, okay, to get their frequency. And what would be the space complexity? Space complexity, since I am storing their frequencies, it would be O of n, okay. Let's quickly code this up. What are we doing first? We are creating a frequency map or a frequency dictionary for all the elements here. So for that, from collections we'll be importing counter. Okay, let's import counter. So what are we doing? We are creating a hash map. So counter is equals to counter of ARR elements. Now after this, what are we doing? We are sorting our counter in terms of their frequencies, okay. The ones with the lesser frequency will come first, okay. So sorted of occurrences array would be nothing but sorted of counter dot items, where key is equal to lambda of x such that x of 1. It means that they are sorted with respect to their frequencies, okay, with respect to the first index. Next, what are we doing? We are iterating over this sorted occurrences. So for num comma frequency in sorted of occurrences, okay. In what are we doing? We are checking if this particular, if k value, we are checking if the k value is greater than or equal to frequency. So if k is greater than or equal to frequency, what is happening? We are decrementing the eliminations by frequency occurrences. So k minus is equals to frequency. It means that we are decrementing the number of elements, okay, the number of occurrences, and thereby the eliminations will decrease, okay. Now for example, if k was 3 earlier and 1 occurs 2 times, okay, and 1 occurs 2 times, what is happening? It means that we were eliminating 1, okay. By doing what? Since we are removing 2 elements here, k will be removed, in k 2 elements are already removed, so it will be left with 1 element now, okay. Now k minus equal to frequency. Otherwise, what is the else case? We are breaking it, okay. We already, that element will remain as a unique integer whether or not you remove it, okay. So that is the case. Now what are we doing in the end? Now also remember that when you are decrementing the frequency, you are updating the counter value to 0, okay. You are updating the counter value to 0. So what happens? Counter of num is equal to 0, okay. So counter of num is equal to 0. In the end, what are you doing? In the end, you are getting the sum of it. So sum of 1 for num comma frequency in counter dot items, okay, if frequency is greater than 0, okay. Frequency is greater than 0, you are adding sum. What does it mean? So after updating its values to 0, we are iterating over this counter dictionary or hash map again to see how many elements have occurrences or frequencies more than 1. It means that they are our occurrences that are present after the removal of k elements. Okay, after the removal of k elements, we are checking how many elements are there. So we will do that if frequency is greater than 0. In the end, we are just returning our answer. Now let's quickly run the code. It's accepted. Let's submit it. Alright, this works. Thank you guys.